Testing one, two, three. Testing, testing. Okay, welcome, welcome. This is our APMOPS 2025 paper. Right, we are going to go through the questions. Just give us maybe 1 minute before we begin, as we wait for more people to join us. Okay, I guess that we can stop waiting. Right, we can just start going through the questions here, right, because I think the time is right. Okay, so hopefully you did well enough in the competition, right? If you didn't do well, it's okay. I mean, this competition itself is not too easy, right? If you take a look at the questions here for today. Okay, let us begin. Okay, let's begin. So question number one here says, a farmer caught 94 rats and 49 squirrels. For the next N days, he caught 3 fewer rats and 2 more squirrels than the previous day until the total number of squirrels caught exceeds the total number of rats caught. Find the value of N. Okay, so how to do this question? So you can see in the first N days, what happens to the rats? The rats go 94, right? 94 minus 3 all the way down to the value of 94 minus away 3 times of n, right? Actually, it's 3 times of n minus 1 if we have n days. So now, the squirrels that we have here, they will be what? They will be 49, then 49 plus 2, until 49 plus 2 times of n minus 1, right? Okay, so he wants the total number of squirrels caught to exceed the total number of rats caught. So then how? That means we need to sum up all everything, right? We need sum of the values here in each of the two rows. So if I take a look at the sum here, what's that? I'll have n times of 94, right? But I also have minus 3 times 2 minus 3 times 3, and so all the way to minus 3 times of n minus 1. So that's minus 3 times of 1 plus 2 plus 3 all the way to n minus 1, right? So that's equals to 94n minus 3 times of n minus 1 times n over 2. In a similar way, if you try to add up the numbers for this particular row, then what do we get? In this particular row, the sum here will be equals to 49 times n, right, plus 2 times of 1 plus 2 times of 2 plus 2 times of 3, or 2 times of n minus 1. So this will be equals to 49n plus 2 times of n minus 1 times n over 2. So we need to make sure that the bottom value is bigger than the top value. How do we do that? I want to make sure that 49n plus this 2 times of n minus 1 times n is actually bigger then 94n minus 3 times of this n minus 1 times n over 2. So if you move the things to one side, 94n minus away 49n, that's equals to 45n, and we move the n minus 3 times of n minus 1 times n over 2 to the left, you can see that this will be 5 over 2 times of n minus 1 times n. So now we can delete the value of n. So you can get 5 over 2 of n minus 1 is bigger than 45. I can divide by 5 and times 2. I can get n minus 1 must be bigger than 18. So in that case, n must be at least 20, right? Yeah, because I want a squirrel score to exceed the number of rats caught. Okay, so this is the answer that we have for the first question. Okay, for today, for the questions, I'm going to go through them a little bit faster than I did for the RMO people last time because today there are 30 questions, right? So I want to also end this not too late for yours so that you have enough time to rest. Let's take a look at question number 2. How many ways to divide 9 people into 3 groups of 3? So the way we can do this is that we can think, okay, first I'm going to choose the first group of 3 by doing 9 choose 3. Then next I'm going to do the next group of 3 by doing 6 choose 3. And then the last group of 3 is automatically determined. But here there's a problem. Here there's a problem because if you choose, right, ABC, then DF, it's the same thing as saying if you choose DF, then ABC. So these orders are the same, right? So if you choose group 1, then group 2, then group 3, it's the same thing as choosing, for example, group 3, group 1, and then group 2, right? Since there are 3 groups, how many ways are there to arrange the 3 groups? There are 3 factorial ways. So you're dividing here by 3 factorial because of the 3 factorial ways of arranging the 3 groups, right? Yeah, so that's the thing we have to divide by because of the repeat. So now if we're going to calculate out what the result of this thing is, we can write down fully. You actually be dividing by 3 copies of 3 factorial. 2 of them from the 9 choose 3 and 6 choose 3, and 1 of them just from the 3 factorial. So now we can realize, okay, 6 and 6 can cancel out. 4 times 9 is 36. You can cancel out the 36 at the bottom. The result of that is equals to 8 times 7 times 5. That's 40 times 7, 280. That's the answer. Okay, so that's question number 2. And then let's move on to question number 3. Question number 3 is one of the most trickiest question on this worksheet. It's not so easy to figure out what is this answer. Find two numbers ABCD where this AB plus CD squared is equals to ABCD. For example, 20 plus 25 squared is equals to 2025. I find some of the other two. So 2025 is one of them, but they don't want. They want the other two of them that will here. If you are a little bit familiar with some numbers, you might be able to get a guess or maybe at least one of them. Right? So for example, if you try, do a little bit of guess and check, you can get an answer of be one of them. But to get both is a little bit difficult. Now, I'll tell you what the result of this thing is first, before I tell you what these two, how to get there. For this question, the answer is you do 30 plus 25 squared is equals to 3025. That's 55 squared. And you do 98 plus 01 squared is equals to 9801. Yeah. So these are the two answers. Now, if you're really familiar with the square numbers, actually you can get this straight away. But let's do this properly. So the way to think about this condition is actually through these two mods, mod 9 and mod 11 that I'll talk about later. So mod 9, what's going to happen? If you notice on the left hand side, this goes to 10a plus b plus 10c plus d, right? Because a and c, they each have a 10. So actually a, b, c, d, mod 9 is congruent to firstly a plus b plus c plus d, right? But a is congruent to 10a, c is congruent to 10c, and so on. So therefore, this is actually congruent to ab plus cd. But this question also says that it is congruent to AB plus CD squared. And this is the result that I have mod 9. So mod 9, these two numbers, they have the same remainder. I negate the case what with the number B. It tells you this thing. It tells you that this AB plus CD, mod 9, is going to be 0 or 1. Because 0 and 1 are only numbers when squared, they are going to be equal to themselves, mod 9. So that's the idea. Okay, so if you do try to figure out what could this possibly be for two-digit number square, then what you can see is that this square number is 0 or 1 or 9. So what kind of square number can it be? It can be something like maybe, okay, firstly, your number, if it's a four-digit number, it must be at least 32 square. So the first number that will be of the form 0 or 1 mod 9 will be the number 36 squared. Then you see 37 squared with the same property, 45 squared, 46 squared. Right? Then you have 54 squared, 55 squared, and so on. Right? 90 squared, and then uh, 99 squared. Then this one is okay, what did I write here? 63 squared. So this one will be 64 squared, 73 squared, 82 squared, 91 squared, and then there's no 100 squared. Yeah, that's too big. So these are the condition we can get for mod 9. What about the condition we can get for mod 11? Turns out pretty similar. Right? Because if you take a look at what ABCD is mod 11, the check for divisibility for 11 is what? The check for divisibility for 11 is going to be minus A plus B minus C plus B, right? Now, minus 1 is the same remainder as 10 mod 11. So again, it's the same as 10B plus 10C plus, right? So again, it's congruent to this ABCD square. But this time, uh, it is going to be mod 11 actually. So they have the same remainder when divided by 11. So again, what you can tell is that this number AB plus CD, right, or this original square number, mod 11 is going to be 0 or 1. So again, you can ask, out of these square numbers, which one of them mod 11 is going to be 0 or 1? Okay. So okay, out of the maybe let me just write down out of the numbers given. So out of the above numbers, we can get 36 is not one of them because 36 mod 11 is 3. 37 mod 11 is 4. 45 mod 11 is 1. 46 mod 11 is 2. 54 mod 11 is not 10. 55 mod 11 is 0. 63 mod 11 is equals to the value of 8. 64 mod 11 is equals to the value of 9. 72 mod 11 is going to be the value of what's this? 6. 73 mod 11 is 7. 81 mod 11 is 4. 82 mod 11 is 5. 90 mod 11 is 2. 91 mod 11 is 3. 99 mod 11 is equals to 0. So therefore, there are only these three numbers: 45 squared, 55 squared, 99 squared. Right? That's why we can see that 45 squared is one of them. The other two will be equals to 50 squared and 55 squared and 99 squared. So therefore, the answer for this question is 3025 plus 9801. And you should get the answer of 12826. It is not an easy question to do. Definitely one of the most difficult questions in the worksheet. Okay, but question 4 is not going to be that difficult because question 4 asks in this triangular pattern, what's the number directly below 2025? Now, in fact, I'm going to do something here. I'm going to write this triangle in a slightly different manner. I'm going to write it as 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, so on. Because if I try to write it in this way, then you're actually able to see where are the square numbers. The square numbers are 1, 4, 9, 16, 25, and so on. The square numbers are all down in the middle column. So when I get to number 2025, what will be the number that's immediately below 2025? It should be equals to the number 46 squared, right? So 46 squared, if you can calculate it out, it's actually equals to 2116. Right? However, 2116 is actually not an odd number. 2116 is an even number, right? Sorry, I think you all are actually unable to see the thing that I'm actually writing down here very well because it's off on my screen. Sorry about that. Okay, my bad. So this is 2116. And then on the left side, we should have the number 2115. On the right side, we should have number 2117. So if you go back to the original case, which one is the number that's below 2025? Well, you can see, for example, in the case of 1 and 3, I go to choose the one on the left. In the case of maybe 9 and 15, I go and choose the one on the left as well. Right? Whenever you have odd numbers, the number that's directly underneath it will be the one on the left. So in this case, the answer will be this number, 2115. Okay, someone asked when are we starting? We already started around 10 minutes ago. Okay, let's move on to the next one. Question number 5. Question number 5 says this thing, the product of two positive numbers is equals to 10 times of their sum. So let's write it down. And this is equals to 15 times of the difference. Now, the one you actually want to start from is the one at the back where they deal with the sum as well as the difference. Because what you can see here is x plus y versus x minus y. What's the ratio? The ratio is the opposite of the ratio of 10 and 15. This is 3 to 2. So if I call, let's say, x plus y equals to 3 units and x minus y equals to 2 units, what will happen? You can determine just by adding them up that x is equals to 2.5 units and then y is equals to 0.5 units. So this will actually be a 5 to 1 ratio. Okay. So now what I will do is that I'm going to use the fact that x equals to 5y. I'll put it back into the equation. So I'll get 5y times y is equals to 10 times of 5y plus y. So I can remove one copy of y. So then get 5y is equals to 60. So y is equals to 12. And once we get the value of y is equals to 12, we can get the answer should be 12 plus x is 5y. So it's 12 plus 60. The value of this should be equals to 72. That is the answer. Okay. Question number 6. Question number 6 is an easy question. I believe anyone here who is doing this paper, they should all be able to do this question number 6. A rectangle of area 1200. If the length increases by 10%, it will become 110%. If the breadth decreases by 20%, it will become 80%. So the area is actually just this thing, which is 1200 times 88%, which is 12 times 88. This is equals to the number 1056. For our next question, question number 7, we are given these three squares on a equilateral triangle. The distance from A to B is represented by A plus square root B. Find A plus B here. So for this question, go and take a look at the number that have been given. What you can realize is that we have forming some nice triangles. So the reason why you're forming some nice triangles is because, let's say I go and draw the parallel line, parallel to AB, passing through this middle line here. Then I can drop some perpendiculars. And the shapes here are going to be 30, 60, 90 triangles. And the reason why you can see there are 30, 60, 90 triangles is because this is a 60 degree, this is a right angle. So if you ask what is the remaining angle, you can see that it's 180 minus 60 minus 90. This is angle of 30 degrees, right? So if you know that they are both 30, 60, 90 triangles, then what is the ratio of the 30, 60, 90 triangle? Some of you should know this, some of you may not. It is 2 to square root 3 to 1. So therefore, if I'm given that the value of the diagonal hypotenuse is equals to 20, we can easily tell that this is supposed to be 10 times square root 3. If I know that this is equals to 20, I can tell that this is supposed to be 10 times square root 3 as well. So therefore, the entire line will be 10 square root 3 plus 10 square root 3 plus 20. This is 20 plus 20 square root 3. But it's not quite in the answer that they want yet. Let's convert the 20 square root 3 to something of the form of square root b. So that's going to be square root of 400 times square root of 3. That's going to be 20 plus square root of 1200. Okay, so a plus b here is equals to 1220. Finish. Next question number 8. Find the smallest integer n such that for any prime number p squared plus n is never a prime number. So how do we do this question? Now the thing about numbers such as form p squared is that they follow something very interesting. Except the very first one, the rest of them are odd. Alright, so for example, 4, 9, 25, 49, Then this one is what? 121, dot, 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 dot. The rest are all odd square numbers, right? So if you can find some kind of odd number to add, if you add an odd number to everything, then the only thing you need to confirm is not a prime number, is the very first one. If you do 4 plus 1, of course it doesn't work. 4 plus 1 is 5, right? It is a odd prime. What about 4 plus 3? Does that work? Once again, you should realize no, 4 plus 3 does not work because it is a odd prime. What about 4 plus 5? Well, this is no longer a prime, right? 4 plus 5 is not prime. And what that means is that the rest of the numbers, they are all going to be even. So they are actually automatically not going to be a prime anymore. So if the first number is not a prime and everything else is not a prime, then we are done. So the answer for this question is n equals 5. Okay, I see a message as well. Is this P5 or P6 syllabus? This is more towards this P6 syllabus side, although there are a lot of P5 syllabus things inside as well. Okay, let's move on to question number 9. Question number 9. Question number 9 is a question which can be done pretty quickly if you use something called the average balancing method. So the way I like to use this average balancing method is like this. I like to draw a line, indicate where 10, 20, and 40 is. So let's say this is 10%. Let's say that this is equals to 40%. Then 20% will be somewhere near the start. So now you can imagine that this is a seesaw. If this is a seesaw, and then you have two people sitting on the 10% and 40%, how heavy should they be? You should realize that if this is a seesaw, the person sitting at the 10% needs to be twice as big as the person sitting at the 40% mark, right? To balance it out. So what you can do is that you can recognize that this is supposed to be 2 unit, this is supposed to be 1 unit of the liquid. So therefore, in this case, 3 units will be equal to the 300 liters. And from here, we can conclude that, therefore, the 2 unit will be equal to 200 liters. And that is exactly how much of the 10% we need to mix with the 40%. Okay, someone mentioned that after looking at the video, I think I got a lot wrong. That's quite unfortunate, but it's okay. This competition is not that easy. Now, let's take a look at question number 10. Question number 10 says that in the year of 2024, February 29 fell on a Thursday. What's the next year in which February 29 falls on a Thursday? So there are two conditions here. Firstly, is the condition of a Thursday. And secondly, it is a thing that's a little bit tricky and maybe hidden from you, which is that February 29 must exist. So firstly, you already know that it's going to be on a leap year, right? So the fact that it's a February 24 tells you, okay, it must be on some kind of a leap year. Yeah. So now you can ask, what happens if we go from 2024 to 2028? What happens in this process? Well, you go and add 365, 365, 365, and then one copy of 366 days for that particular leap year. It is not very important that whether 366 belongs to 2024 or 2028. As long as there is one copy of 366, it's fine. Now, if I want it to be on the same day of a week, then we need to make sure that divide by 7 have the same remainder, right? If you take a look at divide by 7, what happens? 365 divided by 7 is remainder 1, this is remainder 1, this is remainder 1, and this is remainder 2. So therefore, this is actually remainder 5 when you combine all them together. So now this happens every 4 years, right? Because every 4 years we have exactly one leap year. And the next time you won't have a leap year is in the year 2100, which is very far away. So every 4 years, right, we can add a number that's 5 mod 7, right? Because we have these 4 years, they will add a number that is remainder 5 divided by 7. So how can you get back to the same remainder? So for the same remainder mod 7, what you need to do is that you need to go through a total of 28 years. Right? Because we know that every 4 years we get 5 mod 7. So then if I go through 28 years, then there will be 7 times of 5 mod 7. And 7 times of 5 mod 7 is going to be what? It's going to be 0 mod 7, right? So therefore, we know that 28 years will be correct. And there's nothing that's possible before 28 years. Oh, sorry. The answer is not 28. The answer is 2052. There's nothing that's possible before 28 years has gone past because you're going to get some number that's not a nice 7 times of 5. Right? For example, 1 times of 5 or 2 times of 5 or 3 times of 4, 4 times or 5 times or 6 times of 5, they are all have some remainder when divided by 7. So you don't want those numbers. Okay. Let's move on to question number 11. We call the number 1 special and the number that's larger than 1 is called special only if it's a relatively prime with the sum of the special numbers below it. So what does it mean by relatively prime? A relatively prime means that it shares no common factors. So let's try to write down a few terms of a pattern, see whether you can get any kind of pattern going here. So if you have no common factors, what do you start try next? The one. 2, right? 2 has no common factors with 1. Oh, actually, let me mention one more thing. No common factors other than 1, actually. Sorry about that. Sometimes I do forget about the second condition, right? Because to me, it's easier to remember if I just ignore the second condition about uh, no common factors other than 1. Okay, so of course, 1 and 2, the only common factor will be 1, right? So you know that 2 is the next special number. Now, so far, the sum is 1 plus 2 equals to 3. Then what do you do? Then 3, of course, is not relatively prime to 3, right? Because they share a common factor. So you skip 3 and go on to 4. So right now the sum is 7. Is 5 relatively prime to 7? Yeah. Add 5 in, the sum is 12. Is 12 relatively prime to 6? No. So skip. Is 12 relatively prime to 7? Yes. Add 7 in. 12 plus 7 is 19. 19 is the sum right now. Is 19 relatively prime to 18? Yeah. Add 8 in. Now, 19 plus 8 is 27. Is 27 relatively prime to 9? No. Exclude 9. Then you can see it's 10 and so on. Then you might be able to notice a pattern. It seems like basically I only exclude the multiples of 3. Right? I only exclude the multiples of 3. Why is that the case? Actually, if you're doing this on competition and you see such a pattern, I will immediately try to write down the answer. I won't care about explaining to myself why the pattern is true. Because on competition, time is very important. So to me, I just notice, okay, I'm missing 3, I'm missing 4, I'm missing 6, I'm missing 9, I'm missing 12, and so on. So if I'm looking at a 20th special number, what will it be? It will be the number 3 times 10 minus 1. Because 30 is the 10th multiple of 3 that's missing. So that means that 29 is the 20th special number. Right? Because you always have the even special numbers 1 before a multiple of 3. Right? Okay? 2, 5, 8, 11, and so on, they're all 1 less than multiple of 3. But since we are doing a revision, doing a review today, let me explain why we exclude multiples of 3. Firstly, if you add up, let's say up to a certain point, let's say you do 1 plus 2, that's 3, right? If you do 1 plus 2 plus 4 plus 5, that's equals to the value of 12. If you do the next one, that's equals to 27. This is up to 8. You notice that the sum is always of the form 3n squared. So if you add up the first, let's say, 2n numbers, the sum is always of the form 3n squared. And what that means is that you cannot add multiples of 3, right? Okay, you cannot add multiples of 3. Now, what about the next two? Why does the next number can be added? Right. For example, if I exclude the number 9, 9 cannot be added. How do I know that 10 and 11 can be added? Because when we reach the number 3n squared, what is the next number? The next number is actually of the form 3n plus 1. Right. So 3n squared and 3n plus 1, do they share any common factor? You realize the answer is no. Why? Wait, let me try to erase a bit and explain. Okay. 3n squared and 3n plus 1, they do not share any common factor because, firstly, if there's any common factor of these two, it must be a common factor of their difference. Right? And their difference, you can actually try to calculate that. So, for example, you can take n copies of this uh, Sorry, give me a moment. How can I explain why they don't share common factor? Mm, okay. Here's the reason. Because 3, does it share common factor with 3n plus 1? No, right? They do not share common factor. Then n, does it share common factor with 3n plus 1? No, because 3n is a multiple of n. So 3n plus 1 cannot have any common factors, right? So just by looking at these two, we know, okay, 3n plus 1, no problem, we can add that inside. Then using a similar idea, you can actually try to show that the next number that works here, which is this 3n squared plus 3n plus 1, can you add 3n plus 2 inside? Turns out you can. As for why that's the case, I'll leave it up to you to work with on your own. It's pretty similar to the previous result. Try to explain why the GCD of these two is equals to 1. So this also can be added. So that's why our pattern of special numbers is only those that are not the multiples of 3. Okay, let's move on to question number 12. Someone says, can I speak a little bit louder? Let me check my volume. My volume should be okay, actually. I think it should be fine. Yeah. Okay, question number 12. Um, what is the smallest integer in which its prime factors add up to 2025? So question number 12 is a question where I don't really like it because question number 12 requires you to remember the prime numbers that are less than 2025. It requires you to remember that 2023 is not a prime. Now, how do you even remember something is not a prime? That means you have to remember its full factorization, right? So, for example, 2023 itself is equals to 7 times 17 squared. You have to remember the factorization to remember that it's not prime. What about 2021? Is it a prime as well? It is actually not a prime because in this case, 2021 is equals to 43 times 47, right? It is 45 squared minus 4. It's 2025 minus 4. What about 2019? Obviously, there's some 3 times something, 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 right? What about 2017? This is actually a prime. Now, if you didn't remember this fact that 2017 is a prime, then during the competition itself, you'll be spending a lot of time to check the factorization of it. Right? Or if you didn't remember that 2021 is not a prime, you'll be also be spending a lot of time to check the factorization. So that's why I don't like this question. Right? This question tests you on more of your knowledge than actually whether you can do math. Right? Okay, anyway, 2017 is a prime. Why is this important? Because if you want the prime factors to add up to 2025, you want these numbers to be a small number and a big number. I want to have small and big. Because imagine you have two numbers in the middle. Let's say, for example, let's pretend that maybe I don't know what kind of numbers are you going to choose. 1011, 1011, and 3 are all prime numbers. Let's pretend, for example. Then it'll be 3 times 1011 times 1011 will be very big. Compared to something that is smaller. In this case, if 2017 is a prime, okay, someone mentioned they spend a lot of time checking these two numbers. If 2017 is a prime, then what can you do? Then the remaining numbers just need to add up 8. Then you know that plus 3 plus 5 is equals 8. So then the number is 3 times 5 times 2017, which is um, a number that is smaller than the example I gave, right? The example I gave was something like 3, 1011, and 1011. So this is much smaller, right, as a product. So this will be the answer for this question. Okay, so this is equals to 15 times 2017. 15 times 2 is equals to 30. 15 times 17 is equals to 16 squared minus 1. So it's 256 minus 1. This is equals to 255. Okay, let's move on to take a look at the next question. In a secondary school with 4 levels, the ratio of Sec 1 to 2 students is 5 to 4. So I'll draw out my Sec 1, Sec 2, Sec 3, Sec 4 in these circles. Ah, so the ratio of your Sec 2 to Sec 3 will be 7 to 8. So let's draw that down. 5 to 4, 7 to 8, then 9 to 7 here. And then they tell you there are 2158 students in the school. How many Sec 1 students are there? So what's the trick? The trick is that we actually want to make sure that the ratios are comparable. And how we can make sure the ratios are comparable is to make sure that the key thing is the columns of 2 and 3. So here and here, they actually have the same number. So we'll start with the first two things first. I can combine 4 and 7 to form 28 in the middle. But what that means is that 5 to 4 means it's a 35 to 28. Then 7 to 8 means it's going to be a 28 to 32. So this is the first part. Okay, by combining the first two rows. Now I can combine the last two rows together. Unfortunately, the numbers are quite big. Right? So the numbers are going to be what? This number is going to be 32 times 9. This number is going to be a 32 times 7. This number is going to be a 28 times 7. Wait, sorry, 28 times 9. And then this number will be a 35 times 9 for these ratios to make sense. Right, so right now the answers are quite big. I'm sorry, I mean the numbers are quite big. Yeah. And then it's not so nice to calculate. But you should have a feeling by this point that if you add up these four numbers, it is roughly. Okay, wait a minute. What's 900 minus 45? 900 minus 45 equals 855, isn't it? Okay. Then this is the other one is equals to 224, right? And if you check, you do realize this is 1079. It's exactly half of 2158. So if you want the actual total, right, to be 2158, what do you need to do? Since 1079 is half of the total, what you need to do is that you need to multiply each one of these by 2 to get the final numbers. So multiply each of them by 2. Actually, you only need to care about the very first one, which is 35 times 9 times 2. That's 70 times 39 is 630. That's it. The number of secondary 1 students is 630. Someone feels that the questions are different from actual paper. Um, we should have the correct questions. I mean, I'm pretty sure if you look at the paper, you will be able to see that we have the questions. Okay. Which question are you at now? I can look at the screen. Right. I think you should be able to see. Okay, question number 14 here. How many prime numbers are there such that 4900 minus p is a perfect square? So what this is equals to is going to be 4900, right? Minus p is the form n squared. So in other words, 4900 minus n squared is equals to p. And here we can factorize into the form 70 minus n times 70 plus n. So how can a product of two numbers be equals to a prime? The only way the product of two numbers can be equals to a prime is when one of them is the number 1. So it has to be the smaller number that is 1. And if the smaller number is 1, then you can easily see, okay, n must be 69. Then the bigger one will be 70 plus 69, which is equals to 139. Is 139 a prime? You can quickly check. It's not divisible by 3, not by 2, not by 5, not by 7, and not by 11. So therefore, it is a prime. So therefore, in this case, there's only one possibility for this prime number p. Okay, let's move on to the next question. Question number 15. Tom takes 21 minutes to travel to Jerry's house and Jerry takes 28 minutes to travel to Tom's house. They travel to each other's house at 12 noon, then after they meet each other, Jerry will go back to his own house. Okay, so what it looks like this is you have Tom, you have Jerry. Tom takes a shorter amount of time. So Tom has a faster speed, right? So when they travel towards each other, you can see that Tom will be able to meet Jerry and travel more. Now, when they meet each other, then Jerry will travel back to his house at the same speed. So Jerry's pathway is the one in red color here. Question becomes, how long does this take? Well, because the time ratio is 3 to 4, the speed ratio of Tom to Jerry is going to be 4 to 3, right? Opposite of 3 to 4. And the speed ratio is 4 to 3, then when they reach at this point of time, the distance is going to be 4 units and 3 units. So what that means is that at this point, Jerry will actually travel 3 over 4 of his usual amount of time, right? At this point, Jerry will travel 3 over 7 of his usual time of 28 minutes. So 3 over 7 of the usual time of 28 minutes will be equal to 12 minutes. So Jerry will take 12 minutes to reach the meeting point. And then that means that Jerry will take 12 minutes to go back home. So the answer for this question is 12 noon plus 24 minutes, 12:24. Okay, let's move on to question number 16. Question number 16 asks this following question. How many obtuse triangles can be formed by joining any 3 points? So this is not so easy of a question to do. Now, the number of points is small enough that we can just do casework. Right? If the number of points is bigger, then I'll probably do some counting methods. Should I count this? But if it's small enough, we can just do casework. And how do we do this? We will count the number of cases that use the dot point A. And then later on, we can multiply by the right amount of number to consider every single case here. Okay, what do you mean by the right amount of number? Because you can see, right, you can see by symmetry, the fact that there are 12 points here means what? Means how many of them will use A? Means 1/4 of them will use A, right? 1/4 of triangles use A. So we go and count how many use A, and then we multiply by 4. We should be able to get the correct answer. Okay? So that's the reason why we want to consider just point A. Okay, if you consider point A, we can ask what can the other 2 points be? Let's label them B, C, D, E, F, G, H, I, J, K, and L. This is 12 points here. Now, firstly, if you connect A and G, actually anything that's connecting A and G here, that's the diameter, will always form a right angle triangle. This is a fact. So we know that in fact G is not possible. Okay. So let's go and count. So first let's do AB. If it's AB, how many possibilities are there for the last one? You can do ABC, ABD, ABE, ABF, but not ABG, because remember ABG forms a right angle triangle. In the same way, ABH forms a right angle triangle because of the fact that B and H are diameter. Okay, another question say I'm talking too soft. Another person say I'm talking too soft. Let me see if I can do anything for that. Give me one. Let me see. Let me see. Uh, hmm. Maybe I'll speak even closer to my microphone. I don't know whether you help. Let me see whether this helps. Okay, let me continue on with the questions. So AB, I mentioned that CDF works, H doesn't work. What about I? Does it work? Yeah, I works, right? ABI, they will not form they will form obtuse triangle. Then ABJ as well, ABK as well, ABR as well. So how many possibilities are there? There are actually 8 of them here. Okay. So then what we can see is that if I have AB is equals to the value of 8, then let's erase this one because we need the same diagram to draw the rest. What happens if I look at the first 2 points being A and C? Now I no longer want to use the value of AB again, right? So if I use AC, then I want to be able to try to get something that's even more than that. So you can see that we don't use B, we can use D, or we can use E, we can use F, we can not use G, right? As I mentioned before, G forms a right angle. Then all the way until CI. CI is also diameter, so we cannot use that. So the next one will be CJ, CK, CL. Now you can see that there are 3 points on one side and 3 points on the other side. So by this point, you might be able to suspect some kind of pattern already, right? If you move on to the next one, AD, you can see that your pattern will be true, right? Because if you have AD here, then D can go with E, D can go with F. That's the one on this side. And on the other side, you can see that you can go with L and K, but not J, because DJ is actually the diameter, right? So then, this is what we get. And 4 is the answer for AD. So if you continue on AE, how many would that be? There will be 2 of them, right? Would there be anything for AF? No, there's nothing for AF. But now you can actually look at the situation for the other case where you have the number AH, right? AH here, what is that going to be? That's going to be, if you look at it, AH together with the point I, that's going to be an obtuse triangle. AH with the point J, AH with the point K, AH with the point L. These will all form you obtuse triangles. Okay, then HH should be 4. In a similar way, you can go and figure out that AI will be equals to 3, right? And in a similar way, you can go and figure out that AJ will be equals to 2. And then you can figure out that AK, the final one, will be equals to the value of 1. So therefore, the ones that use point A, how many are them actually? The ones that use point A, you can see that if you add up, you can see that there are 30 of them. Right? 8 plus 6 plus 4 plus 2 plus 4 plus 3 plus 2 plus 1. And if you have 30 of these, then you can see that, okay, if I expect 1/4 of the triangles to be able to use A, then what should the answer be? The answer should be 30 times 4, isn't it? So the answer should be 30 times 4, and exactly 120 of the triangles should be obtuse. And that is our answer. Okay, so this question is a little bit tedious, right? It's a little bit long. Let's move to the next question, question number 17. Question number 17 says, using these 27 regular dice to form a 3 by 3 by 3 cube, 1 6 opposite, 2 5 opposite, and 3 4 opposite, what's the largest sum of the numbers that can be faced outwards? Now, if any of you did the RMO paper, you realize, hey, wait a minute, this question feels a little bit similar, right? But in that paper, it is not 1 6 2 5 and 3 4, right? In the paper, it's something else, where 1 and 2 are opposite, 3 and 4 opposite, and 5 and 6 are opposite, right? Okay, in this case, for a 3 by 3 by 3 cube, if you draw and count, you can easily see that there will be, okay, let me draw it out first. There will be one cube at the very center. Right, the one cube at the very center, it will not get exposed to any of the outside surfaces. So there's no number that's facing outwards. So there's number of cubes that has uh, zero face, zero face shown. There's actually one of them right at the center. Now, how many of them has one face that are shown to you? If you want something that has one face shown to you, then actually it has to be one of these 6 positions, right? That I draw in the star. And then there's 3 of them at the back as well. So you can see that there will be 6 of these faces, so 6 of these cubes that are showing one face. Okay, so this is something that I have as well. Now, how many of them will show, let's say, 2 faces? If they show 2 faces, you can see that this one is one of them, this one is one of them, this one is one of them, this one is one of them. And then you can go and see that this one is also one of them, this one is also one of them, this one is also one of them, and so on. Okay, if you go and count, you can find a total of 12 of them that show 2 faces. And finally, how many of them show all 3 faces? These are the corners of the cube, right? So the corners of the cube, they are all going to be all 3 faces being shown. Okay, there are 8 of them here. So the video keeps cutting the sound. Okay, I'm not sure what that means. Okay, so if you have the 3 faces, right, the fact that if you have 8 of them having 3 faces, what would these 8 show for the maximum number of sum? These 8 faces, they will show 6 plus 5 plus 4, right? For the maximum sum. What about those 12 of them with 2 faces? These 12 of them will show a 6 plus 5 for maximum sum. What about the 6 of them with 1 face? They will show 6. And then the one of them with 0 face cannot show anything, right? So of course, there will be no sum. 8 times 15 is 120. 12 times 11 is 132. 6 times 6 is 36. The sum is 288. Okay, so that is the answer for this question 17. Let's move on to this question number 18. Question number 18 says, right, a four-digit number is nice if it has only one pair of the same digit. Right, for example, 2025, the 2 repeats, 1997, the 9 repeats. But numbers such as this are not nice numbers because two of the pairs they repeat, right? We don't want that. How many four-digit nice numbers are there? So we should recognize that firstly, the digits that are possible, they are of the form AABC, right? Of the form AABC. So we can talk about how many ways for us to choose this A, B, and C. Right. So firstly, if you take a look at the digit, the first one, the first digit can be a digit that is basically not a digit zero, right? Not a digit zero. There are going to be nine possibilities. The second digit must be something that is different from the first digit. There are also nine possibilities, right? Even though it can be a zero. And then the third digit must be different from the first two. So there are eight possibilities. So what that means is that for any choice of AABC, right, any way of arranging it, there are nine times eight ways of doing it. Now, how many ways of arranging AABC are there? The answer is actually just 4 choose 2. And the reason why it is equals to 4 choose 2 is because we just need to look at the positions of the A's. Right? For example, A something something. That's different from A something A something. That's different from A something something A. That's different from something A something A something something A. And finally, this case here, right? So you have 6 different cases of the positions of A. And each one of them will give you 9 times 8 possibilities for your digits A, B, and C. So the final answer is going to be 6 times 9 times 9 times 8. If you calculate it, you will be able to get 3,888. Okay, next question, number 19. Question number 19, they want you to find the area of the shaded regions. So how to do this question? Now for this question, actually they are testing one important technique that you might or might not know. It is called similar triangles. So when triangles have the same shape, their ratios of the sides are also going to be the same. For example, you can see that in this question, let me highlight out the similar triangles for you. It is this small one here and the big one outside here. These two triangles, they actually have the same shape, right? And you have the same shape, then they have the same ratio for all their components, right? Okay, they have the same ratio for all the components, and if they have the same ratio for all the components, then what you can see is that the ratio of the heights will also be the same. So if you take a look at the ratio of the height, this is going to be 24, this is going to be 8. So the ratio of the height is going to be 3 to 1. 24 to 8. And if the ratio of the height is 3 to 1, then the ratio of other particular things about this triangle should also be 3 to 1. For example, you can notice that if this base is 24, then naturally the base of the purple color triangle should be equals to 8 as well. And once we know that this is equals to 8, we are actually done. Because once we know this is equals to 8, we know that the other two base, they will be able to add up to a value of 16, right? The one in green color, you can see, is sum to 16. Do we need to know what they are individually? We don't need to know, right? We don't need to know because we are concerned about the sum of areas. We're not concerned about the individual areas. So in this case, the sum of areas will be equals to half times the base of 16 times the height of 8. That's equals to 64. Okay, someone mentioned the 0, 0 can be used for the previous question. Yes, I considered that already. That's why I have 9 possibilities for the second digit, not 8 possibilities for the second digit. Okay, question number 20. The area of a rectangle whose length is twice its breadth is equals to something, something, something. So when something says length is twice its breadth, I like to just use the algebra. you can use the fact that it's 2 units to 1 unit. Let me just use x itself. So for example, if I have the length is equals to 2x, right, and the breadth will be equals to x, then the area will be equals to 2x times x. Yeah, that's what the question means. And now they say, if you decrease the length by the value of 14, and then you increase the breadth by the value of 8, it will be the same area. So that means if you take the length minus 14, and if you take the breadth plus 8, it's the same, right? 2x times x. Okay, so what we have here is 2x squared is equals to the value of, here you notice a 2x times x is a 2x squared as well, right? Then the remaining three terms will be minus 14x plus 16x, and this will be a number of minus 14 times 8. Okay, so if you remove the common number 2x squared, then actually we can see that 14 times 8 is equals to 2x, right? 16x minus 14x is equals to 2x, and that will be the same thing as the value of the 14 times 8 that we have right here. So now, what's the value of x? You can just divide the value here by 2, right? So x itself is going to be 7 times 8, that's equals to 56. And we want to use this 56 to be able to calculate the perimeter of the new rectangle. What is that equals to? The new rectangle is going to be, here we don't even need to actually calculate 2x minus 14 and x plus 8, right? We notice that, okay, if it's a 2x minus 14 and if it's x plus 8, then the sum, or rather, let's take a look at the perimeter, will be 2 times of 3x minus 6, isn't it? Right? So that's equals to 6x minus 12, and 6 times of 56 is equals to 336. So this value here will be equals to the value 324 cm as the parameter. Okay, let me move on to the next question. Question number 21. There is a 4-digit number. Okay, firstly, this question number 21 is actually quite difficult. It's not that easy to get an answer because this question, the condition is actually a little bit challenging. Okay, what it says is that there's a 4-digit number. If you add 9 to it, swap the last two digits, and then swap the first and third digit and double the result, you can get the original number. Sounds like a whole entire mouthful, right? How do you write this thing down here? Now, the thing you want to start with is actually the last condition. This last condition is very important because it tells you one thing. It tells you that it is even. And when you know it's even, you know the last digit is going to be 0, 2, 4, 6, or 8. The last digit, there isn't that many possibilities, right? So let's try to see what are the possibilities here. Let's say the last digit is 0. So I'm going to call the number ABC0. ABC0 plus 9 is what? Is ABC9. Swap the last two digits, AB9C. Swap the first and the third digit, 9BAC. And then times 2. But of course, 9BAC times 2 is not a 4-digit number anymore. It's going to be a 5-digit number, right? From here onwards. And this tells you something important. This tells you that, okay, if my digit by this point, it reaches the first place, if it's a number that's more than or equals to 5, it is immediately not possible. So when can you get the first digit here as being something that is going to be less than or equals to 5? Originally, if you add 2 to 9, there's a 1, right? Or rather, it ends in a 1. If you do 4 plus 9, it ends in a 3. If you do 6 plus 9, it ends in a 5. If you do 8 plus 9, it ends in a 7. So these two are not possible because those two you will end up with either a 5 in front or a 7 in front. So now you know your correct answer must be one of these two options here, which is either ABC2 or ABC4. Okay, ABC2, let's add 9. That's going to be AB, if add 9, it's going to be C plus 1 for the third digit, and then 1 for the last one, right? Swap the last two digits, AB1C plus 1. Swap the first and the third digit, 1BAC plus 1. And then this number, when we try to multiply by 2, hopefully it can end up with my original number here, which is ABC2. Okay, like that. So what is the possibility? Now, the one they want to focus on is B. If B times 2 equals to B, there's only two situations here. Either B is equals to 0 and there's no carryover at all. No carryover from here, no carryover from here. Or B is equals to 9. And if B is equals to 9, there must be carryover from here and also a carryover from here. So it's either B equals to 0, then both no carryover, or B equals to 9 and both are carryovers. So here, let's try the case where B is equals to 0. Right, B is equals to 0, then A is equals to 2. And if A is equals to 2, then you realize that A times 2 ends in C, and C plus 1 times 2 ends in 2. Then if you try through a couple of possibilities, you realize that C equals to 5 actually works. So there's actually a solution here, where A equals to 2, B equals to 0, C equals to 5, and then the value will be correct. Because 1026 times 2 is 2052. So then my original number will be the number 2052. Okay, and so that will be our answer. Okay, if you want to, you can quickly check through the other case. The other case here, it will not work because in the other case, what will happen? In the other case, what will happen is that you look something like 3BAC plus 1 times 2 will give you the value of ABC4. Right, here you can quickly check through just to work it out yourself if you want to, that A must be a 6 or 7. And if A is a 6 or 7, then C can only be a 2, 3, 4, 5. And no matter whether C is 2, 3, 4, or 5, C plus 1 times 2 can never end with 4. So this case is going to be wrong. Okay, so 2052 is the only answer. Okay, question number 22. Question 22 is a question which I don't really like as well from the competition. It's because this question is just a pure algebra question. It is not possible to really do it without using any algebra. Okay, so let's take a look at what it means. You have this files, 17 of them. Pens, 25 of them. Erasers, 19 of them. In this case, they will sum to $25. 23 files, 21 pens, and 31 erasers will sum to $36. So then you want to find somehow they can give you 56 files, 108 pens, and then 52 erasers. Right, somehow. Now, you should be able to realize that it is not so easy to somehow get 56 from 17 and 23, 108 from 25 and 21, and 52 from 19 and 31, right? So to do this, we have to use a bit of algebra. We know that we need to use both of the equations to get the answer, but how many of each equation? Well, we don't know, right? So let's say I call the first equation A. So it's A times of the very first one, and let's say I call the second equation B. Then it's B times of the very second one. Okay, so I use the first one A times, and I use the second one B times. Then now what we can see is that somehow 17 times A together with 23 times B, they must give you 56. Okay, let's write it down. 17A plus 23B is equals to 56. Then for the next one, somehow A times 25 plus B times 21 should give you 108, right? Okay, let's write it down as well. 25A plus 21B is equals to 108. Now the numbers here are quite disgusting, right? If you notice the two-digit numbers 17, 23, 21, and 25. And furthermore, to get the numbers, you don't really, you have to kind of multiply huge numbers. Right? For example, if you want the A to be the same, you need to multiply, for example, the first one by 25, and then the second one by the value of 17, which is not nice. So one thing I can notice here is I can take the difference. 25 minus 17 is going to be 8. So 8A here. Then 21 minus 23 is what? Is negative 2, right? So this is 108 minus 56, that's 52. So 4A minus b is equals to 26. Okay, so this is what I have so far. Now, how do I find a or b? The way I find a or b is maybe I can use this one together with either the first equation or the second equation. Let me choose the second one here. So we'll multiply what we have here at the back by a value of 21. Then I can get 84a minus 21b is 26 times 21. Right, so already there's a big number that appear. But this is not too bad to calculate because this is a 420 plus 132, right? Let me check it. 420 plus 420 plus 126, sorry. 420 plus 126 is 546. Okay, and then if I combine this equation and this equation together, then the result I'll get is 109a is 108 plus 546. That's equals to 654. So dividing by 109, 654 divided by 109 is exactly 6. So we can get a must be 6. A must be 6, then put inside, for example, this equation, 4a minus b is 26. What do you get? You get that b must be negative 2 fact. Right, so here you have to deal with negative numbers. B must in fact be equals to negative 2. Okay, so that tells you the 6 times of the first equation minus 2 times of the second equation will give you 56 and 108. You can do a quick check here. Does 6 times 19 minus 2 times 31 give you 52? 6 times 19 is equals to what? 6 times 19 is equals to a value of 120 minus 6 is 114, right? Minus 2 times 31 is going to be minus 62. 114 minus 62, yeah, that gives you the number 52. So indeed, we can figure out from here, A must be 6, B must be negative 2. And so from here, we can get the answer. The answer is just going to be 6 times of $25 minus 2 times of $36. This is 150 minus $72, which is $78. That's our answer. Okay, so you can see why I don't really like about this question, because the entire question is just a big mess of algebra, right? It's just whether you know how to do this or you don't. Okay, let me move on to question number 23. Okay, this question here it says, how many numbers smaller than 2025 are there which is coprime to exactly 1 of 20 or 25? So we already saw something that means coprime, right? This is relatively prime. And if it's coprime to exactly 1 of 20 and 25, what must happen? That means that it will not share common factors with exactly 1 of them, right? So it share common factor other than 1 with 1 of them, but not share common factor with 1 of them. So what you can think, can this common factor be equals to 5? The common factor that shares with either 20 or 25, is it 5? Well, the answer is no, it is not 5, right? Because if you want to have exactly 1 of 20 and 25, then 5 is the common factor of both of them. So no. So if it's not 5, then what can the common factor be? The common factor must be equals to the number 2, right? Because we can see that 2, it is a common factor with 20, but not a common factor with 25. So basically, what do we want? We want a number that actually has a common factor, right, of 2, or we even don't even need the word common factor. So factor of 2, right? Factor of 2, but actually not factor of 2. The factor has 2, right? 2 is a factor. Let me rephrase it. 2 is a factor, but not 5. We cannot have 5. So how many such numbers will work? Let's start easy. Let's start from 1 to 10. So 1 to 10, we realize, okay, 2 will work, right? And then 4 will work, 6 will work, 8 will work, but not 10, because 10 is a factor of, sorry, 5 is a factor of 10. So from 1 to 10, 4 numbers work. So this will be true for every single one. So 1 to 10, blah, 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 all the way to 1991 to 19, sorry, no. if you stop at 2025, then it is 2011 to 2020. Again, there will be four of them, right? There will be four of them here, there will be four of them here, there will be four of them all the way until the very last one. They will all be four of them. Okay. Dot, 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 dot. Then from the number that's remaining, 2021 to 2025, what happens? Or rather 2024, you can see that only the two of them here works, 2022 and 2024, right? So the last one is a case of two of them instead of having four of them. Okay, so you have four of them for the first how many groups? From the first, from the first, let me see, this is 0001 to 2011, right? So this is from 0 to 201. This is 202 groups, 202 groups of four. And then we add in the last option, which is two of them. So therefore, we can see this is 808 plus 2. This equals to 810. That's the answer for this question here. Oh, the question in the exam is either. But either doesn't make sense, right? Either 20 or 25. Okay, the question in the exam is either. But either 20 or 25 doesn't quite make sense because then why is 25 there? Right? Then you can tell me why is 25 there then in that case? Because if it's coprime to 20 already, right? Then it will be coprime to 25 by default. Because if it doesn't share a factor of 5, then of course it will be coprime to 25. So if it's coprime to either 20 or 25, then it's coprime to 20 already. Does that make some sense? If that's the case, then I think they set the question very badly, right? If they use the word either. Okay, let's move on to this question number 24. Question number 24, for those of you who have taken RMO, you'll get a sudden flashback at this question, right? Because this question here, it is going to be something that is um, something that you recognize. But the question in the RMO is actually going to be a 7 by 7 table, right? That one was a 7 by 7 table, if you remember correctly. If you remember correctly, it's a 7 by 7 table, and then what they're going to be, the solution is pretty much the same. We first take a look at the very last row. Last row, if you want the sum to be divisible by 5, then 2 plus 3 is divisible by 5. 1 plus 2 plus 3 plus 4 is divisible by 5. 5 itself is divisible by 5, right? And of course, the big group of numbers 1 to 5 all the way is actually going to be divisible by 5 as well. Okay, so this is the situation that we have. Now, we can see that there are 4 possible rectangles on the very last one. But if I'm using the last row here, I'm only using the top and bottom as these two choices. When in fact, in reality, I can choose, for example, the 2 and 2 and 3, I can choose something like this. This will also be a multiple of 5, right? Because every single one of these groups are not a multiple of 5 when you add them up, right? 2 plus 3 is a multiple of 5, 7 plus 8 is a multiple of 5, 12 plus 13 is a multiple of 5. So this one will work, for example, and then this one will work, for example, and so on. Okay. Someone mentioned that the question numbers are not accurate. Indeed, the question numbers are not accurate because we received them in some random order as well, right? Okay. So what it means is that for these rectangles, these 4 rectangles that we have here, I can actually replicate them. I can replicate them and into with the top and bottom being any two choices out of these 6 lines here. So I can choose any two of these 6 as my top and bottom. So this is a 6 choose 2. And I have 4 such rectangles here. So that's 6 choose 2 times 4, which is equals to 60. So there are 60 rectangles that look like this way here. Now, but they are not the only one that works. Let me show you another type of rectangle that also works. Another type of rectangle will be when you use everything from the top to the bottom. So for example, if you use this one, this works because of the fact that all 5 numbers, they have the same remainder when divided by 5, right? So if I add up the 5 numbers from top to bottom, they'll work. And I can do this for any one of the uh, columns. So for example, I can do this for the second one, I can do this for the third one, I can do this for fourth one, I can do this for a combination of, like, for example, columns 3, 4, and 5. This is also something that can give you divisible by 5, right? So how many are there? Well, we know that our top and bottom have to be fixed, but our left and right side can be any of the other 6 choose 2. So in this case, also 6 choose 2, 15. So in this case, these 75 rectangles, they actually have some kind of overlap. What are the overlapping rectangles? The overlapping rectangles are the ones that are in both the brown color type and the purple color type. So what does that mean? There are exactly 4 of them. The overlapping rectangles are the ones with the 2, 3 going all the way from the top to the bottom. 1, 2, 3, 4 going all the way from the top to the bottom. Alright, 5 going all the way from the top to the bottom. And finally, 1, 2, 3, 4, 5 going all the way from the top to the bottom. These are the 4 rectangles that overlap. They are both considered under the purple color case and also under the brown color case. So we need to remove these 4 possibilities, right? So the answer will be equals to 60 plus 15 minus 4, that's equals to 71. Okay, and that's the answer for this question. Okay, 6 questions left over. Let me move on to question number 25. Here, this question is not too difficult. It says that on the left, these 3 segments are the same. On the right, these 3 segments are the same as well. So from here, you can see, okay, there are some parallel lengths in the middle. The area of this EFCB is 27. What's the area of triangle AGD? Here, one option is to use similar triangles. Another option is to just cut the triangles up into smaller shapes. So for example, one idea is to do this. You cut like that, cut like this, cut like this, cut like this. Right, where all these red lines are parallel to the sides of the triangle. And we do it this way, then we can see, okay, 3 unit is equals to 27. The area of the entire triangle is 9 unit. That should be equals to 81. That is the answer. Question number 26. In the figure, the radius of these circles are 4 cm, 3 cm, and 1 cm. And the radius of the shaded semicircle on the right is equals to 1 cm. If the ratio of the area of the shaded to the unshaded regions is m to n in a single form, in the simplest form, find m plus n. How to do? Here, the most important thing for this question is actually not really area, but more of ratio. Right. For example, let me give an example. A circle with radius 1, a circle with radius 2, a circle with radius 3, and a circle with radius 4. What's the area ratio between these 4 things? If I know that, let's say the length is 1 to 2 to 3 to 4, you should be able to see that the area ratio is going to be 1 unit to 4 unit to 9 unit to 16 units, right? Because the pi value is the same. And then we only care about the radius squared. So it's going to be 1 times 1, 2 times 2, 3 times 3, and then 4 times 4. So now we can already see a few things. We can already say that, okay, this thing here will be 1. Okay? And for the other part of the shader, I can cut out like this. What's the part on top? I can call it 0.5. What about the part below? The part below, I can think of it as the big semicircle over here minus off the slightly smaller semicircle. So the big semicircle will be half of 16, right? Because we assume that the big one is 16 units. Then the small semicircle will be half of 9. So the result of this is half of 7, which is 3.5. Okay, so this part we have here is going to be area of 3.5. Therefore, the shaded is going to be 1 plus 0.5 plus 2.5, which is 5. And we're assuming that the entire shape is going to be 16 units. So ratio of shaded to unshaded is going to be 5 to 11. Right? This is the value of shaded to unshaded. And therefore, when we add up the answers, 5 plus 11, we can get 16 as the final answer for this question here. Okay, let's continue on. Question number 27. This is a slightly tedious question. They say that there are 6 identical square sheets of paper that can be white or black. Then how many different 2 by 3 rectangles can be formed? Rectangles formed by rotating and floating, rotating and flipping are counted as the same. So if they're counted as the same, then wow, there's a lot of cases to consider, isn't it? Right, white here, white there, black there, how to do? Now I found an idea that makes it a little bit nicer, which is to count based on how many white or how many black you need. For example, okay, let me draw out some rectangles because I need them. Okay, for example, in the case where you have the 6 white, then there's only one way to do it, right? White, 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 white. Okay, so 6 white is very easy. There's only one way. What about 5 white and 1 black? There's going to be 2 ways. It's either the white is at one of the corners, it's either the black is at one of the corners, or the black is in one of the 2 middle positions. There are these 2 ways only. Right? Everything else can be flipped or rotated to one of these 2, right? You can, not B. Right, everything else can be flipped or rotated to one of these 2 positions for the black color. So 5 white and 1 black, there's only going to be 2 of them. What about, let's say, 4 white and 2 black? Right, so this one here will be a little bit more tedious. Let me try to arrange them, see if I can do it nicely. So here, the black color, they can be both at the side. There can be one in the corner, one in the middle. They can be both in the middle. Right, some situations like this are possible. But there's more. There can be 2 of them at the top. Right, 2 of them at the top, right beside each other. There can be also one of them at the far corner, one of them at the 2 of them at the basically the diagonally opposite corners. So if you have 4 white and 2 black, it's actually quite tedious because you need to be able to see that all these cases they exist and they are all different from each other. Right? Okay, so there are 6 cases for the 4 white and 2 black. Now this also settles what? This also settles 6 black, 5 black and 1 white, 4 black and 2 white as well. So the only last case we need to do is the case of 3 white and 3 black. Okay. 3 white and 3 black, how many cases are there going to be? So again, let's go and explore. Here again, there's a little bit too many. If I don't measure fit in, I'll move on to the next page. Okay, let's fit in the cases for 3 white and 3 black. So again, I'm just going to list out the black color shape. So I can have all 3 of them at the top. I can have 2 of them at the top and 1 of them at the bottom. So 2 of them at the top, what kind of situation can I have? Actually, if you realize, all 3 of these are different. Right? All 3 of these are different. What else is there? There's also going to be B, 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 and B, B, B. Like that. But that's it actually for 3 white and 3 black. Because why? Because if let's say your on top is 1 black and your bottom is 2 black, then you can always flip it around and get one of these situations, right? Where the top one is equal to 2 black. Right. Of course, if the top one is 0 black and the bottom is 3 black, you can flip it over and get the first situation on the left. Right? So here, that's why over here we only consider cases where the top part is 3 black or the top part is 2 black. Okay, so that's it. This is all the things we need to list down. How do I add them up? There is 1 for this one, 2 for this one, 6 for this, and 6 for this, right? 1, 2, 6, and 6. For 4 black, 2 white, it's going to be 6 as well. For 5 black, 1 white, it's going to be 2 as well. And then for 6 black, it's going to be 1 as well. So therefore, the sum for this question is equals to 24. That's the answer. Okay, so this is a pretty long question, but we managed to do it in the end. Huh? Meanwhile, question number 28 is a really simple question. How many positive integers x are there such that x over 3 and 3x are both 5-digit numbers? X over 3 is what? X over 3 is going to be at least 10,000, right? Yeah, because for this to be a 5-digit number. 3x is going to be at most what? 99999. That's the largest 5-digit number. So combining these two things together, we can conclude that in fact x must be between $30,000. No, 30, not thousand. Sorry, x must be between 3,000 and the number 33333. But it's also a multiple of 3, right? Because we need to make sure that x over 3 is a 5-digit number. Okay. In other words, x over 3 is between 10,000 and 11111. So there are 1112 such numbers. Finish. Final two questions. Or just bear with me for a moment. Question number this 29 here. Two different positive integers are called a beautiful pair if the smaller number is at least 25% of the larger number. And at least one number in the pair is between 25 and 28 inclusive. How many beautiful pairs are there? Let's say that I have one number being 25. What can the other numbers be? The way I think about smaller number being at least 25%, it also means bigger number cannot be more than 4 times the small number. So the bigger number is at most 100. Right? 25 cannot be more than 4 times of the small number, so 4 times 6 is a bit too small. So the smallest case is 4 times 7, right? 7 is at least 25% of 25. Same thing for 26. The biggest one is 4 times of 26 is 104. 4 times of 6 is still smaller, 4 times of 7 is still bigger, so the bottom part is still 7. If one of them is 27, then the numbers are from 7 to 108. If one of them is equal to 28, then the numbers are from 7 to 112. Right? So how many pairs are there? Now in the first case, 25 can be paired with a number that is other than 25, right? How many numbers other than 25 are there here? 100 minus 7 plus 1 minus 1. The last minus 1 is because I need to remove 25. So there are 93 numbers here. Same reasoning, 104 minus 7 plus 1 minus 1, you see that it's 97. Then next one, there will be 101 numbers. Next one, there will be 105 numbers here. So if I sum them up so far, is equals to 198 times 2, 396. But then this answer of 396, it will be wrong. It will be wrong because there are some pairs that overlap. Pairs that, if you choose numbers from both, from all of 25 to 28, they will overlap, right? For example, you choose 25, 26 two times in the first row and in the second row. So you need to remove how many pairs? You need to remove 4 choose 2, which is 6 pairs, right? Because every single one of the pairs from 25 to 28, they get counted twice. So you need to remove them. Finally, the answer is 390. Okay, we have our last question here. How many ways are there to color these 8 different regions of the rectangle with 4 colors so that no two regions bordering each other have the same color? Now, when we have such a question, we want to be able to start from somewhere in the center because it's usually easier to start from the center than from the outside. So I noticed that these two shapes here, A and B. I want to consider what happens. Now, it is actually different number of ways to color if A, B are the same versus if A and B are different. So we need to separate cases here. Case 1, A equals to B. If A equals to B, then there are 4 choices for A. If there are 4 choices for A, then how many for the rest? There are 3 choices for this one because it touches both A and B. There are 2 choices for this, touches both A and B. There are two choices for this and two choices for this because it touches both A and B. So there's so far 4 times 3 times 2 times 2 times 2. Now on the left is very interesting because on the left you cannot do casework on these two, right? Because you don't really know uh, what these two are supposed to be. Okay, so to make it easier for ourselves, let's call the colors red, blue, yellow, and green. What's happening on the left? Let me give you an example. Let's say that, for example, we already figure out that this one here is going to be a red color. Let's say we figure out that this one here is going to be a blue color. This one here is going to be yellow color. How many ways to fill in the other? It can be GP, or it can be YB, or it can be YG. That's it. Right? If you can try for yourself, if you don't believe me, the other possibilities must be GB, YB, or YG. So actually, these two regions combined together, there are three ways. So it's not that they themselves have some number of ways, right? It's that they combine together, they have three ways to do it. Okay, so case one where A is equals to B is actually 4 times 3 times 2 times 2 times 2 times 3. I'm not going to calculate this yet. You understand why later. Let's take a look at case 2 where A is not equals to B. Where A is not equals to B, the numbers are going to be a little bit more different. Um, when A is not equals to B, you're going to start with 4 choices for A, 3 choices for B. And then what happens? Then you're going to left with 2 choices for this one because it must be different from both A and B. You're going to left with 2 choices for this, 1 choice for this one because it must be different from A, B, and the one on top. Then there are 2 choices for this, then there are 2 choices for this. So far it's 4 times 3 times 2 times 2 times 2. And then on the left side, the same thing will happen, right? On the left side, we know that there are going to be 3 ways here, so it's times 3. So if you notice, case 1 and case 2, they actually have the same total number, right? Because the expressions for them are the same. So now you just need to calculate any one of them and then multiply by 2. So for example, in this case here, you get 4 times 3 times 3, that's 36. 36 times 8, I don't know what that is, but once I combine it together, it will be 72 times 8. 72 times 8 is equals to, let me see what's the value, 576, isn't it? Okay. So in this case, there should be 576 different ways for us to do it. And that will be the answer for this question 30 reps. Okay, so it took us quite a bit of time to go through everything. Hopefully you managed to understand everything that was being taught here, and hopefully this has benefited you. Right, that's all. Yeah. If you have any questions, you can stay back and ask. Otherwise, maybe yeah, you can leave. Yeah. Yeah, if there's no more questions in 1 minute's time, we will end the stream. Okay, that's it then.